Ladies and gentlemen, Michał Żyliński will be now talking about artificial intelligence. Please give him a warm welcome.
Good afternoon. My name is Michał Żyliński. It's the first time, actually the third time I'm talking at PyCon in Poland. But for all of you that are somehow considering becoming a PyCon speaker, a word of warning: if you ever consider that, check the agenda. If you're right after Disney, think twice. Especially at my position. I work in Microsoft. Microsoft is typically connected to Python, according to what I hear in the communities. But I'd like to somehow verify this position. I do similar talks about different Python initiatives inside Microsoft almost every second year, because I believe we have something that might be interesting and valuable for you. This time I'd like to talk about Cortana. Cortana is supposed to be the hero of today's talk. Don't know how many of you know about Cortana. Does this name ring a bell for some of you? Okay, I'm pleasantly surprised. So this is basically Cortana. She's a teenager. She's 14 years old. For the first time, you could see her in one of Microsoft Studio games. Our blockbuster titles called Halo. And Cortana was basically artificial intelligence that took significant role in this game, in a series of games actually. So now she's a teenager, and there was another retake on Cortana roughly 2 years ago, when we started to brand Cortana our set of services that are available both on our mobile phones and just recently also on our newest Windows 10 operating system. So Cortana now is a personal assistant. It's not just about fictional character, it's also a personal assistant. It's a service that you can ask for. But just very recently, we also announced a different Cortana, the third version of Cortana, and that's basically a set of analytical services that are available to all of you who are willing to build some sort of sophisticated analytical solutions, but are not willing to invest too much time into that. So Cortana, I thought about it for a while, and even though I like nice teenagers, I decided that, to have a special spin into the story, I needed to find some other hero for the talk. And actually, when I started to prepare this presentation, roughly Monday afternoon, I had 3 days to basically create the storyline. I decided, all right, this is basically my hero. Do you recognize this one?
Pac-Man.
Congratulations, congratulations. This was the front-facing Pac-Man character. And that would be actually the story of Pac-Man. I decided to go with Pac-Man because I thought, okay, it should be somehow entertaining, especially if you're right after lunch. And I somehow compete with Disney, so guess what? So Pac-Man actually celebrates the 35th anniversary this year, so I think it would be a good idea to somehow celebrate it also here. He was born in 1980. Originally he was called Pac-Man, but for some reason it was renamed because some English-speaking countries were complaining about this name. I don't know why actually. Of course, it has a large fan base, but I believe it somehow needs some refresh or update, especially as there are some new generations of children that are basically not so familiar with this topic. So I decided to start with Pac-Man, and actually I found a nice implementation of Pac-Man game. It wasn't developed by me, it's basically using Pygame engine, and it has been developed roughly 6 or 7 years ago, so it's quite a solid piece of code. It was done by David Rayleigh. The code is publicly available at GitHub. So I decided to somehow move Pac-Man towards 21st century. And what would be better than basically trying to achieve what we have right now? So of course, multiplayer, multi-user experience, sharing experiences, tweets, and all that stuff. But let's start with something. Just a bit of warning. This session is supposed to be highly interactive. And I'm not really talking about you versus me, although I'm still counting at some questions from you guys. But I'm talking about you versus my computer and also some internet services. So I really hope that it's gonna work fine. I have a bunch of demos prepared as well. So I started Monday afternoon, Monday evening to think about what would be the project scope of the story. That's quite easy. Okay, let's try to start with something easy. So we would like to have like a worldwide championships in Pac-Man. We have a client game. Now we have now we need to provide some service that would collect at least basic high-score data coming from multiple users. For that, of course, we would need some sort of telemetry information, and that's something that I need to develop. So that was not originally the plan of the game. So that's a sort of extension of the original project. Then it would be good, once I have this telemetry, to have almost real-time monitoring of the players, right? To see basically what's going on. If I'm hosting a gaming platform, of course, it might be crucial to have at least basic understanding of what's going on there. And then, actually, the whole idea started to get really complicated because it would be good to somehow also detect malicious traffic, so also protect our servers or services against hackers. And that's, of course, the coolest part of the story, but we need to wait for until the very end of the talk, so beware. So when it comes to telemetry, I basically made up a very simple schema. What I need actually is 3 events, actually. So the first one is called start. It basically is the event that is raised when the player starts the gaming session. The second one is score, so that's basically every time when user scores any points in the game. When basically Pac-Man eats any dots or ghosts or whatever, that's basically when score is getting sent. And then of course the last one is stop, when the player sees the game over page, right? So that's very, very easy. All events are basically implemented using JSON format, because that's easy and both to implement and to interpret. And all of them are sent separately, so I'm not using any sort of batching. That's highly inefficient, but for the purpose of the prototype, it would make sense. So this is basically sample user session, as you can see. The user called Michał Z, which basically is me, has some session ID. It's basically gaming session, and is starting the session. Then he basically has some scoring events. In total, it basically creates a value of 410 points. So that was a very short game, you can see. So I wasn't very successful in that, but still that's basically just a sample. So, short demo of what basically the game looks like, for those of you who are not aware of what Pac-Man is. So this is basically the code of the game. As I said, that's basically something that is available on GitHub, but it was extended with those events that I was talking about. I believe I've turned on debug mode, so if only I would be able to play it. It's coming. And here's our Pac-Man, sorry. It's getting complicated a little bit. We need to see also the console. So if I start the game, you can see basically that all those events are basically generated. This is something that I'm going to collect. Actually, it's quite cool. This is the first time I'm allowed to play a video game in front of the audience, but okay. So we have the client. Now, what about the data? For that, I'm using Cortana. So Cortana is basically a set of services that allows me to create very simply and efficiently this sort of solutions. So if you look at the Pac-Man, the new release of Pac-Man, we can look at the whole project from the data pipeline perspective. You can see basically that we have an event producers. In our case, is of course our client game application. Then there should be some sort of collection endpoint or mechanism, scalable if possible, and protected, flexible, etc., etc. For that, I'm using the service called Event Hubs. You may, of course, consider some other ways of talking to your platform, like RabbitMQ or Kafka. Those are perfectly valid as well. I've decided to go with the fully managed ways. I don't care about what basically stays behind Event Hubs. I'm just happy that it's able to digest my JSON messages that are coming in. Then, of course, it's all about analytics. And for that, we can use either very simple solutions like databases or large-scale data warehouses or real-time engines like Apache Storm, let's say. I decided to go with another managed service called Stream Analytics. And that's basically something that I feel really proud of, because it took me roughly 30 minutes to go through all that pipeline until the endpoint, which in my case is basically some sort of visualization of the data that is coming in. So talking about stream analytics and actually any sort of streaming in general, it's good to somehow understand what are the properties available. And typically it's just about some business logic, but the crucial part is all about the timing, right? So for some reason we need to understand what is the sequence of events, how actually we should interpret it, how actually to efficiently aggregate those events, and there are different sets of time windows that are currently available. So this is basically the first one, and this is the one that I've chosen. You can see basically that here we are just defining the size of the window. Like in this case, it's 20 seconds. So every 20 seconds, we collect all the events that appeared in our pipeline, and we are applying some sort of transformation, some sort of aggregation, let's say. And what's really cool about it, I'm just using SQL syntax. It's nothing more than SQL, or actually slightly more than SQL, because those time extensions are part of it as well. So there is tumbling window, then there is hopping window, which is quite similar to tumbling, but basically we can define separately the size of the window and also the step of the window. So you can see that some of those windows can overlap with each other. And the last one is sliding window. So this is basically the situation when we define the size of the window and it continuously moves, but it only generates some events when the signals are appearing. So for example, if there is no one playing, I will not be receiving any information, which is of course quite important. So basically, this is how I implemented this hop path. By hop path, I mean getting real-time or almost real-time access to the user data. So to all the players that are currently playing my game. If we'll have a look at Cortana portal, which is part of our cloud services. We start with Event Hub. As I said, we can use Kafka, we can use any other queuing mechanism. The good thing about Event Hub is that I don't need to care about scalability. I don't even know the infrastructure in the back. I just care about the incoming messages. So this is basically my Event Hub endpoint. And if you had a look here, you can see basically the connection string to my endpoint. This is basically the part that I've implemented in my client app. So by basically parsing this connection string and then sending some messages, I'm able to transmit some events into my platform. So you can see basically that starting from October the 14th, I started to send some messages to the system. And that's of course totally fine. The other thing, something that I really like is stream analytics, as I said. So I need to connect Event Hub to some business logic. Again, it can be custom code, of course, it can be Python or Java or Scala, whatever you like. But in this case, let's say I really need to do it quick and dirty. And this is basically the pipe that I'm using. It's called PyCon dashboard. And here I just need to define several things. First thing is, of course, input, so where the events are coming from. In this case, of course, obviously it's my event hub. You can see basically event hub has been defined here. Stream Analytics currently supports different different event formats. It can be JSON, it can be CSV, or it can be Avro, which is quite popular in the big data community. But that's basically one part, so those are the events. On the other hand, of course, we have outputs, so where that data that has been processed by the engine needs to land. And for that, if we switch to output, have we lost connectivity? Hopefully not. Let's refresh. Here it comes. I have several different outputs, so that's another nice story. I'm not dependent only on single output, but I can have a few of them. In my case, I'm using SQL database because I would like to have like a transactional information, especially my high score data in a relational database, because this is quite convenient for me. I'm also throwing all the raw events directly to the files. So this is why I'm having here a blob storage. And then for this real-time information, I'm using a different output format, which is called Power BI. And I will tell you what Power BI is in a minute. But let's have a look at the logic itself. So if I look at the query, this is basically what I'm processing here. So for security reasons, I'm using an explicit schema of the event. So you can see basically that I'm expecting the event, the JSON message that will contain this sort of information. User ID, session ID, event type, and event value. So this is basically the schema that I've described to you several minutes ago. And then based on that schema, I can apply some selects. So the first select is basically trying to gather all active sessions. By active session, I mean everything that happened over the last 5 minutes. So I'm selecting user ID and I'm counting all sessions IDs. This way I will see basically how many users are active over time. And then I'm sending it to active sessions. So if you look at outputs, that's basically the name of my output. I'm of course using like a typical SQL syntax, so from Pacman, I also try to filter out the events looking only at the start events here. And this is basically how I define the size of the window, so 5 minutes is expressed like that. Then there is another select as part of the same business logic, so I select user ID, event value, and time, so basically timestamp, and I send it straight away to high scores. And for high scores is basically my SQL DB. And then of course the last one, I believe, I'm also collecting recent events in total, and as I said, I'm throwing all the events directly to a text log, just for debugging purposes. So it should work, and to test if it's working, we can switch to the next part of my project, which was actually, let's call it a website, a global website that will present the best 50 players globally playing Pacman currently. So if you look at this website, it looks very retro. And I'm sorry for that, I'm not front-end developer. That's very simple Django website that is hosted as part of the project. You can see basically all the scores of the recent players. That's not very impressive, you must admit. So to have better view into the data, I'm actually using Power BI, which is a separate service that gives me this nice view on what is happening right now. And basically, Power BI is not supposed to be anonymous service is sort of an administrative dashboard. You can quite easily replace it with your own favorite tool. It's web-based. It's also working on any sort of mobile or desktop devices using client apps. But here you can see basically the whole view on all the events that are happening in my platform. So here are basically number of incoming events. You can see that I've done some performance testing. You can see how many events were generated from my laptop during the last few days. You can also see score seasonality, so you can see basically when exactly those high scores have been collected. You can see how many events were processed through the engine, also most active users, etc., etc. So this is basically all alive, and I didn't do any sort of coding to have this sort of nice visual experience. So this was the hot path. So quick and dirty, I can have a visualization in a matter of few hours, let's say, from the beginning of the project. This way, I hope I covered part of the story. So I collected the events, then I used event hubs to have this huge buffer to collect all the data. Then I applied some stream analytics logic to have a nice visualization, either using my custom web page or Power BI. So the last part is definitely the most interesting one, at least for me. So this is how can we do something more on top of it. And when it comes to hackers and the traffic that appears in such systems, we might expect basically any sort of behaviors. Sometimes it's quite easy to implement those rules. So as long as we are able to define those rules before actually the actual attack, we can of course implement it as part of the business logic. But sometimes it's getting tricky, of course, and the real hackers are not really script kiddies. They are using very different strategies, quite often also a multitude of different strategies. So I just made up a few of those strategies. What might get wrong with this sort of approach that I've implemented? The first one is basically different event frequency. So let's imagine that I've publicly exposed my protocol, and everyone understands what's going on in the back. So I can imagine that some of the users might be willing to implement sort of bots that will be generating a series of events, trying to get the high score. Another thing, of course, is the situation when that some of the scores might be out of bounds of the game. So let's say that instead of 10 points, some users will be generating 10,000 points, even though it's totally illegal. When it comes to protocol and existing processing, that should be valid, but we need to protect ourselves against that. And the third situation that I made up is basically the one when the total score, that is part of the stop event, is different from the sum of all the individual scores that appeared in the past. Of course, we need to have some sort of margin because we might lose some events. Typically it happens if we are dealing with multiple users and many million events a second. So we need to be maybe a little bit cautious about it. But in this case, the typical answer is machine learning. So when it comes to hackers, it's all about anomaly detection, right? So it's a perfect example of anomaly detection case. Those sort of scenarios you may see implemented, in banks, in finance companies, in retail companies, in multiple places. Those are just a few examples of anomaly detection, fraud detection. As I said already, when you are paying something with credit card, you may very easily go through a fraud detection system. Manufacturing defects, very interesting case when you are having, let's say, a factory. You are having a factory line, and then you need to somehow monitor the quality of the product, and also detect potential defects in the product. It also makes sense when it comes to your internal infrastructure. I've seen a couple of customers that are basically using anomaly detection to track internal network traffic in the organization, just to see well, what wrong could go, what errors might appear in certain circumstances. So, talking about machine learning, for those of you who are not familiar with machine learning at all, this is basically a sample workflow, how basically you operate with a large amount of data. We typically start with some data set. So for us it would be like a session data, something that you've seen already as part of the JSON files. So we are having this input data set. In this case it's really simple one. And this particular example basically covers the situation when we'd like to predict what will be the income of certain person based on all those features that are stated in gray here. So based, for example, on age of the person, work plus education, how much he or she will earn. So once we have input data sets, typically we need to do, the next step is process called feature selection. So in most of the cases, not all of those features will be relevant. So we need to have good understanding of what's going on and also filter out those that are basically useless for us. And then once we have feature selection ready, so we have the data set that is already cleaned up, we need to split that data set into two parts. One is basically part that will be used for the training, and another one will be used for testing. So for training, we simply apply one or few machine learning algorithms. This way we are creating a train model. And then once we have the model ready, we simply verify how accurate it is using the testing set. So the train model is basically scored using testing set, and this way we can evaluate the performance of the model. It would be good that once we have the model ready and we are happy with its performance, to somehow make it public, because one thing is of course to do this sort of statistical or mathematical exercise, but another thing is making it operational. So even if I will be able to find what are the hacking patterns into my gaming systems, I would like to make use of it in my production system. So how can I do this? And for that, let's switch to another demo and another service called Azure Machine Learning, which is another piece of Cortana suite. So Azure Machine Learning is something that is available as most of those services free of charge. You can basically make use of it, especially if you're learning machine learning. It's quite convenient. It's just visual tool, highly extensible using, for example, Python, and that's basically part of my story. That's basically the ultimate tool for the data scientists or data miners, anyone who is willing to build and publish their own models. So if you look at the process itself, we need to start with reading the data, right? So basically this is how you read the data. I've created already a sample of gaming sessions. This is basically how the sample looks like. And there is one little difference between the original sample that you saw already and that one, because the last thing is the last column here called label. I've created, let's call it gamer simulator. So this is basically maybe not so simple, but Python script that generates this sort of traffic, but also takes into account hackers and those different hacking strategies that I've covered. So I've implemented 3 hacking strategies that those hackers may implement, and I also defined in the script how many of those users are actual hackers. In this case, it's roughly 10%. So if you go through all those details, the label basically means if it's hacker or not. This is definitely something that would be required for our machine learning model, because we need to somehow help our model learn. And this is basically how we are pointing it to a proper direction. So we've read the data, we've converted it to CSV, and then we can open a new notebook. Notebook basically is not new idea, is another website. I don't know how many of you are familiar with JITAM or notebooks in general. Just a few of you, okay. So this is basically JITAM Jupyter. Sorry, that's Jupyter, not JITAM. Jupyter is one of many projects that are currently available on the market that basically provides you with very nice, let's say, experience, especially for the data scientists. So this is the place where you, on one hand, have full markup support, so you can basically document your thinking process, like a notebook, of course, and then a full Python environment embedded into it. So this way you can start with playing with some data and exploring it using this nice visual way. So let me switch to two of the notebooks that I've already created. The first one is very simple data exploration. So let's say I don't have the clue what actually the data contains. I'm just beginning my work, I just received this data from my IT department, and I'm willing actually to explore it further. So this is basically a whole documented project, as you can see. So the first line is basically automatically generated. So this is how I connect the notebook to a particular data set in my experiment or in model. This is how I look at the data. So it's basically pandas plus numpy plus scipy. All those nice libraries are included as well. So this is basically how my data looks like: timestamp, user ID, session ID, event type, label. Basically the same what you saw in Excel. Then of course we can start to do some stats on top of it. So this is basically descriptive statistics like count, means, standard deviation, etc., etc., etc. That's not very interesting maybe for you. Then I need to convert those features into categories, because by default some of them might be treated as strings. For me those are categories. So I have in this data set, I believe, 10,000 gaming sessions, and I would like, of course, to keep them as they are. And the last part, basically, when it comes to data exploration, is trying to seek for outliers. So I don't know what was the hacker strategy yet, but I might have some clues or some guesses about it. And this is basically how I do it. Let's basically try to calculate the average session time, because I may suspect that some of the users might, for example, have high score even though they played just for 10 seconds, which is, of course, not possible in real world. So it might be some sort of abuse. So this is how I generate basically session time. I'm just removing all score events from my data sets because I don't need them anymore. I'm just keeping start and stop. I'm applying pivots to that table. So basically the first one will be my session ID. I have my start time, my stop time, and of course I'm just subtracting it to have a session time, as expressed in seconds here. So you can see basically first 5 of the sessions, most of them are roughly 25 seconds long. That might be okay, that might not be okay, so let's have a look at the graphical view. This is basically the box plot. So you can see that even though the majority of the sessions are roughly this 25 seconds, there are some that are significantly below that range. So that might be somehow suspicious to us. You can also look at the histogram of it. And again, you can see quite easily that there are 2 different groups of users. Majority and this bad minority, right? We need to do something with that. So let's switch to my second notebook. Again, we are starting with reading this data frame, but this time the purpose is different. We know or we suspect that there might be some users with bad habits, let's say, but we'd like to implement proper model. We need to change the data set itself. Because we are starting with the data set where in every row we have a session event. That's not really that important when it comes to machine learning, because it would be better for us to keep in a single row all information about user session. So I need to transform this huge data set. It's like 50,000 rows. Maybe it's not that huge, of course. In real time it would be much bigger. But for that, we need to basically move from this per events to per session approach. And for that, this is basically the process. Again, we are connecting to the data frame. We are calculating total session time, because that's quite easy. We already have it as part of our stop event. Then we are calculating the sum of individual scores. I said one of the strategies might be that customer simply sends total session score, which is much higher than the sum of individual scores. We need to keep track of that as well. So we are calculating sum of individual scores. You can see basically here that that's the vector. Then we are calculating also average event delays. So this is something that I was mentioning already. We are basically keeping track of all the events and the delays between them, and basically averaging the value across all the sessions. So you can see that typically the average event delay is roughly half a second. Then we are also taking total score value and label from our events and merging everything into one data set. So this is basically what I will be using as an input for my machine learning model. It looks quite different. Instead of having events, I right now have session ID, session time, individual scores, event delay, total scores, and label. And of course, at the very end, I'm simply saving it back to my model, to my service. So, getting back to Azure Machine Learning, it's gonna be here. Let's look at how an actual model looks like. It's really very simple. It's just a few boxes. It's just this diagram. So just let me move closer. And we are starting with the data set that we've created. So if you right-click here, you can visualize the data, and you can see basically the exact data set that I presented to you after my experiments with Notebook. So it's 10,000 rows, 6 columns, everything is fine. We have label that will be used for training. The next step, as I said, is splitting this data set into two parts, train and test. So we are having a separate module called split. 80% of that rows will go to training, 20% will be used for testing. Then we are using train model, where we simply state which of those columns is basically our label. So which one basically states who is the hacker or not. And for that we are using logistic regression, which is one of the classical algorithms. If I would like to have something more than that, there is a bunch of others. So let's say that we are interested in classification, because that's basically a classification question. We need to classify those two behaviors into different buckets, so proper users and hackers. So for classification, there is a bunch of algorithms available, like decision trees, neural networks, perceptrons, actually anything you might probably imagine. If there's anything missing, you can simply throw here either Python or R code, which is equally supported. So it's, as I said, fully extensible. We are training the model and then scoring it against our tests. So this is basically 20% of the data that will be coming as a test set. And then, of course, you may evaluate the model and see how it performs. We can even visualize it here. This is basically one of the classical approaches. It's called ROC. Basically, what is important for us, the more this curve is towards upper left corner, the better the model performance, right? So this way, we can simply assess how many true positives and true negatives we've had. You can see that there were no false positives, so we haven't accused anyone incorrectly, but there were a few false negatives. So the question to potential analysts, is it okay for us or not? This way we can of course compare different approaches, different models. We can connect not just one algorithm but several of them and see the results. And the last part, of course, the coolest thing is the fact that we can publish it. Of course, it would be good to, for example, get that code, that Python code that we've just used in the notebook and put it as part of the model. We can do it as well, because if you do it like that, you can very easily connect data set and generate new data sets using this sort of approach. So this is perfectly valid, Python, and of course it's again Python sandbox. What is really cool that it's fully multi-tenant, so all those boxes may be running in separate machines, which is quite interesting for people dealing with large amounts of data, because for example if you're experimenting iteratively, those different calculations will be done in parallel using different infrastructure. So this is not a single server or set of servers, it's basically, it's scaling out. So once we have this ready, we can of course publish the model, and you can see basically that there is a nice button here called Setup Web Service. We simply turn the model into a single API. And I have this API created. This is basically how the final model looks like. You can see that there are some web services inputs and outputs defined. This is actually automatically generated. I haven't done much about it. And once I have web services, I can call them using the API that is exposed through here. You can see full documentation. Those are the specs of the requests, and also there are sample Python code that we can simply embed into our solution. So this way we can extend this rule-based, quite simple queries that we've applied onto our stream of events with some highly sophisticated business logic using some statistical mechanisms. Okay. So this is of course just one part of the story. We can use machine learning in this particular case for many other purposes. This is just a few examples that came to my mind. So for example, I can easily try to define or create user behavior profiles. So for example, it would be good to separate hardcore gamers from newbies, just to motivate them equally, because if there will be just a single global league for the players, it might not be very relevant. For that, we'll be using mostly clustering and classification algorithms. We, of course, and that's very common nowadays when it comes to gaming industry, we should think about game monetization. So how can we turn those rankings into cash cow? So, for example, trying to upsell or cross-sell some additional features, Pac-Man skins, bonus equipment, anything like that. This is probably a regression that we can apply here. And of course, matchmaking players, cross-selling new services, that's of course the story for recommendation engine. All of those three scenarios can be easily implemented using Azure now. So, what else is missing? We have a prototype ready. It would be good to somehow think about how to make it work on large scale. This part is definitely missing, especially when it comes to data processing. This feature extraction process might be quite compute intensive, as you might have noticed. So for that, I would rather say it doesn't make sense to implement it as part of machine learning process. It would be probably better to put it separately. And for that, I would probably choose some sort of Hadoop or Spark environment that can be spun on top of that. And another thing, aside from operations, it would be good to somehow automate the whole process. So as I said, you can think about this new release of Pac-Man as a data factory or data pipeline. So how can actually we can monitor and automate this process? Yet again, another service, this time it's just called Data Factory. And what Data Factory is basically a data pipeline that will connect all those separate pieces that I've just created. This is basically not relying on my Pacman anymore. It's actually one of the samples that is coming out of the box from Azure Data Factory. And it's about Halo. So we are getting back to Cortana, and that's how you can implement your own data factory or data pipeline yourself. The best way to look at the data factory is actually to look at the diagram, and this is basically the whole data process that is happening here. You can see that there are a bunch of different services loosely related to each other. So for example, we are having blob storage to keep row event stable. So this is something that I've just emulated. And then we apply some sort of transformation here. You don't know actually what the transformation means, maybe beside the name itself, which means partition game logs. So we are trying to, of course, partition the logs using certain approach. We can double click here and see what's behind that activity. And for that, oops, let's go back. Yeah, so you can see that this is something called HB inside Hive activity, which basically means that there will be some Hadoop cluster running in the backend, processing those logs that were generated by my games, and then putting it into some other place. So we are consuming one dataset and producing another dataset using Hadoop cluster in the backend. And actually, I don't care what that Hadoop cluster does, as long as I really do care about it. So in this case, I can simply have a look at the actual Hive query that is responsible for this data partitioning. So one of those activities, getting back to our diagram, can be, of course, aggregating data coming from different sources. Here we are simply collecting data stored in different files or directories. But it can come from multiple sources like databases or data warehouses. Those are all fully supported. And one of those activities can be calling our machine learning model. So this way we can bulk load all the session data that we've just collected based on, let's say, last 4 hours of our user activities, and then batch load it into our machine learning model and see who are the potential candidates for some drill down, let's say. So coming back to Cortana, Cortana is basically a set of services. Most of them I've just described, hopefully in some practical manner, that are currently available on the market. As I said, significant part of them are available free of charge. I highly recommend having a look at least part of them. I really like especially machine learning, so we provide a bunch of tutorials, courses, and examples as part of the service, which basically can translate into any tool. I think that ML is a nice one to start with. There are some parts that I haven't touched, and you can see, for example, on the right-hand side of the slide, business scenarios. And those are basically not just the tools or platforms, those are actually something that you can very easily implement into your own service, let's say. So we do provide recommendation API. If you're running e-commerce site or any sort of site that somehow might depend on user recommendation or product recommendations, you can take it out of the box. One of the coolest parts is basically those APIs, this perceptual intelligence part, which is quite interesting because I've heard in the morning session some information about image processing on a high-fidelity image processing using GPUs. And we are basically they're delivering something very similar. I don't know how many of you have seen one of the nice demos that we've presented during one of the conferences called How Old? Have any of you have seen it? Just a few of you. All right, so that's basically the service that is relying on those APIs. And this is actually how old you can find it here. Project Oxford is a set of APIs that we are delivering currently, free of charge. You can see face APIs, speech APIs, and computer vision APIs. And I must say that those are quite impressive. So if you look, for example, at computer vision, you can see feature analysis. So those are sample images. You can see, for example, of course, the basic information, metadata coming out of the picture, like if it's black or white, but also some quite sophisticated things like is adult content, right? So this way you can quite easily filter out the images that are not appropriate for certain audiences. You can also see here that we implemented a dictionary of the categories. So here you can see basically that there are some people swimming, and this is the probability that this assessment is true. So if we switch, for example, to some other picture, let's take, what could we take here? Maybe this one. You can see face recognition, number of images, number of faces, estimated age of the person, and also if you dig deeper, you can see full biometrical information about each of the persons of the picture. So those are things that are available out of the box. At the peak time, our demo, howold.net, was processing roughly, if I remember correctly, 2,000 images per second. So it's quite production-ready system, let's say. But that's just part of what we provide as a set of APIs. So if you're interested, have a look. So, short wrap-up. Cortana is about making lazy programmers happy. I'm definitely a lazy programmer. I probably would refrain to call me programmer at all, but that doesn't matter. I spent 3 nights, evenings, working on this particular case, particular scenario. I probably would not be able to do it using lower-level tools. Cortana is also about making your work relevant to your users. So that's definitely about time to market. It's definitely about saving your resources and to do something more appropriate. As you may have noticed, I have not used any sort of server-side coding. I have not, deployed any VM or physical server. I have not run any sophisticated application server or whatever. It's all coming by connecting different existing services. And Cortana encourages idea sharing, as I said, especially when it comes to machine learning community. We are investing a lot in that. Also when it comes to examples, lessons, and there is a whole set of communities who work around those topics. And thanks to managed services, as I said, almost no server-side code was required. I just needed to inject a few events into the client-side application. So I highly encourage you to join Data Revolution. This is basically the website of Cortana's gallery. You can find a bunch of other samples as well. And guess what? We are hiring as well. I just checked yesterday, there are literally 100 jobs that are tagged Python that are available inside Microsoft. This is, of course, this might be surprising, and it's not just about Python developers. It's just one of the requirements that we are trying to express explicitly. So if you are interested in any sort of those topics, including hiring, let me know. I will be here for at least 1 or 2 hours. Thank you very much. Are there any questions? One question.
There's a question.
Hello. How could we, for example, deal with overlearning problems, for example, with neural networks provided via Microsoft Azure machine learning services?
So, of course, we are providing a bunch of neural networks algorithms as part of machine learning. So you can have a look at that. I believe we are also providing some sort of neural network specific syntax to express the network model. If for some reason you would be missing any sort of features or parameters or whatever, we highly encourage our users to extend it with either Python or R. We've just, or maybe not just, but at the beginning of this year, we acquired a company called Revolution Analytics. Those are basically guys behind R, commercial R distribution, and of course it's sort of a pity that I'm talking about R in front of Python audience. But that's basically the case. So for all R-oriented or new agnostic, let's say, data scientists, those tools will soon appear as part of Azure as well.
So if I understand you correctly, each model provided by Microsoft Azure Machine Learning has its own, for example, API to extend it by any kind of Java, Python code.
Yes, so absolutely. All those models that actually it's not us. It's you that are creating those models. Of course, part of those models are commercialized and are provided by us as a product, as a recommendation API, let's say. But it's about your models being exposed through REST API that can be fully consumable using Python, Java, or any other language.
That's amazing. Thank you.
We have time for one more question.
And I forgot to say I've got some prizes for the questions.
Hi, great talk. I have a question. How much does it cost? If I want to put my really large data set to Azure, how much does it cost?
Well, it depends on the service. Azure ML is actually starts for free. Up to 10 gigs of data set is basically for free. You can make use of all the features that are part of the platform. What is not available for free is publishing the model. So as long as you are just learning the tool, exploring the model, you are happy with the results, then it's fine. If not, the prices start, I believe, at $10 per month per user. So that's basically.
How much does it cost the storage?
The storage itself is very cheap. As in all cloud vendors, we are charging per gigabyte. It's like a few cents per gigabyte, so it's nothing.
Okay, if you compare it to the Google or Amazon?
The same price, I would say roughly the same price. So we are not competing. We try to keep the same prices as our competition. Any other questions?
I see there are no other questions. Thank you so much.
For two brave ones, we do have books here, so please come.
Yeah.
Thank you.